Okay, example 2 is very similar to the first one. We've got a particle that's projected horizontally again with speed 15 meters per second. Right, so it's gone off like that. And obviously the trajectory of it, right, is going to start off going across and then it's going to come down like this. Okay, and this is up to a point where we're 3 seconds, so when t equals 3, part A asks us to find the horizontal and vertical components of displacement. Right, what on earth does that mean? That means the horizontal component is how far across it's travelled and the vertical is how far down. So if we were to draw ourselves a little diagram like this, this would be the vertical component, let's call it y, and this one would be the horizontal component, let's call it x. So what we're looking for is from the start point to the time t equals 3, how far has the particle travelled down and how far has it travelled across. In order to work this out, we're going to resolve it vertically and horizontally, just like we did in the previous question, and like you will in all of these projectiles questions. So the first thing we're going to do is we're going to resolve it vertically. This time I'm going to resolve it vertically, but with the downwards direction taken as positive, right? Just to show you that you can do that as well. So when we take the downwards as positive, it will be very similar, right? We're trying to find s. We know that t equals 3. We know that the initial velocity is 0 because in the downward direction there is no velocity. It was only horizontal velocity that it started with. And the thing that pulls it down is the gravity. Now, because I've taken downwards as positive, the acceleration this time is going to be in the positive direction. So it's just a positive 9.8. Okay, other than that, it's exactly the same. So let's find that. If we use the formula for s, so s is ut plus 1/2 at squared. Right, so this is 0 because u is 0 plus 1/2 times 9.8 times 3 squared. So pop that into our calculator and we should get 0.5 times 9.8 times 9 is 44.1 meters. Okay, so that tells us that we're 44.1 meters below where we started. So that's this y value here that's 44.1, and this length here will be 44.1. For the other part, we're going to do exactly the same. We're going to do it horizontally. And horizontally, we know that u was 15. We would still like to find s. We know the acceleration is 0 because horizontally the acceleration is always 0. Gravity does not affect it, the speed in the horizontal direction, so it will stay at 15 for the whole time. And we know that t is equal to 3. So again, s equals ut plus 1/2 at squared. But because the acceleration is 0, this whole term on the right is going to die just like last time. So we've got that s equals 15 times 3. So s is 45 meters. Okay, and that's going to be this value here. So we're 45 meters along from where we started. That's part A done, right? There's two answers to part A, 44.1 and 45. And then all we need to do is part B. And for part B, I'm just going to draw another diagram. It asks us for the distance. So remember, the distance does not take into account the direction that you've actually travelled. It wants the straight line distance. So if we look at it here, the distance between these two is going to be that orange line that I've drawn. And as you can see, to find the distance, well, we know x and y, I've circled them there, they're 44.1 and 45 squared. We're going to use Pythagoras, right? If you've got the two elements of the displacement, you want to get the distance. The distance is the straight line, so we're going to use Pythagoras. So what we're going to do is we're going to do the square root of 44.1 squared plus 45 squared and square root our answers. So see what that comes out with. That's 63.0, so it's 63 meters to 3 significant figures.